Right then, assess 23, this is question 9. I'll probably just do one video just for this question alone. Not that it's overly complicated, it's not. It says that the cross section of a tunnel is the major segment of a circle. In other words, that is the major segments of the circle, all this part here, and that's like the major arc, and this would be the rest of the circle. And I will draw it in so we can see what the problem is. So that's, if it was a completely circular tunnel, it would look like that, but it's not. It goes, it goes round like so. Just join it up. It goes round like so, and stops there, and then we have a flat part there through which a train or car go. Now, right, so here we go. Cross section of a tunnel is the major segment of the circle with radius 3.2. That's easy. Thankfully, it's a nice easy angle called 90 degrees. We can handle that. And the tunnel is to be 0.75 of a kilometre long. So imagine this going back, you know, back over there somewhere. So this is going flying over there in that direction. So this is going back there, off into the screen, up into the sky somewhere. So imagine it's a great big cylindrical hole. Alright, so that's what's happening in the story. And the question is, how many cubic meters of rock must be removed to make the tunnel? How many cubic meters of rock? Okay, so once I work out the area of this part here, what they've called the major segment here, I can then multiply by the length of 750 meters. So it goes back a distance of 750 meters. Alright, I've just converted that into meters because the radius is in meters, and if you end up with mixed units, we end up with a wrong answer completely. So essentially I've got to work out, if you like, the area of the entire circle, which is easy. Work out the area of the triangle, which is very, very easy, especially as I only have a 90-degree angle to play with. So I know it's a quarter of a circle, part of a quarter of a circle there. I need to work out the area of this entire segment here. Alright, that entire thing. And segment or sector? Yeah, no, sorry, this sector here. Got to work out the area of this sector here and gradually eliminate that little part there. If I get rid of that little part, I've got the area of this entire sector, and that little triangle will come into play as well. So bit by bit. So let's just take it one stage at a time. Let's do the area of the entire circle first. Circular face is going to be pi r squared, which is 3.14 times the radius squared, 3.2 squared. That came to 32.1576 meter squares worth of area. So all of that is 32 point something meter squares. Got to do the area of triangle as well. I'm just building up the ingredients that I will need to do the final answer. So area of triangle is going to be half base times height, which is going to be 0.5 times the base. Well, it's 3.2 each end. Let me stand out a little bit. That's 3.2. Imagine that's the base, that will be the height, or that could be the base, that could be the height. Doesn't matter if it's 90 degrees, it's just very clear. So half times base, which is 3.2, times a height of 3.2, and that came to 5.12 meter squares. Then what I did was to work out the area of this entire sector there. Alright, this sector, this portion of a circle, which is a quarter of the entire area. So area of sector, let's just call it, yeah, sector, right, is going to be quarter of pi r squared, which is going to be the whole area, 32.1576 divided by 4 comes to 8.0384 meters squares. Okay, I know there's lots of little answers here, but I do need them. So let's just work out the area of the tunnel. To have the area of the tunnel, I need the area of all this, and including the triangle, but excluding that little segment there, the minus segment, if you will. So that's the minus segment. In other words, a smaller bit of the circle. Alright, so what I did was I took my entire area of the whole circle, so let's call the area of tunnel face is going to be the whole circle, 32.1576. Then I want to take away the area of this sector here. In other words, take away a quarter of it away, and that will be take away 8.0184. But then I want to add on the area of my triangle. Okay, so add on my area of my triangle, which is 5.12. Let's think about this. So I've got the area of the whole thing, take away the area of a quarter of the thing, which leaves me a quarter of the circle missing. Then if I add on the area of just the triangle, then I've got the area of the part that I want. Okay, so I've got that, and therefore that's what's required in the question. That's easy. Back to yellow. So hold the whole circular face, take away a quarter of the circular face, add on the area of the triangle, gives me the red shaded bit that I want, and that comes to 29.2352 meters squares. Okay, very, very easy. Now to get the volume, of course, it will just be the area of the face multiplied by the 750. Therefore, volume of rock is going to be the volume of this tunnel here. It's going to be 29.2352. Multiply that by 750 meters deep. That comes to 21,926.4 meters squares. Sorry, cubed. We're in volume, aren't we? Now there's a comma there, and that's approximately 21900 meter cubed. Excuse me. Working to three significant figures, and I think it's 3SF anyway here. Yes, it says work to 3SF, so there it is. So 21,900 meters cubed worth of rock need to be hewn out of this mountain. I presume we're going to drive through a mountain. Either way, that's the correct answer, and that is quite nice. Okay, so that's that, question 9 done. I now need to prep some more, and I'll catch you quite soon.